Okay, you notice my student work got no mention of normality because we already, meaning our data, we already clean it using another function, right? But for your case, your normality, as I said, SPSS, I told you, right, you can use that range or whatever you use. You put it together with descriptive statistic, meaning after you describe the statistic, you extend the table, meaning you can either extend the table or you put a separate table to report. Maybe you're using skewness, kurtosis, you use your graph, QQ plot, whatever. You just extend accordingly. Understand? And then report for each variable. If you use Jack Bera, because Jack Bera is one tiny statistic, isn't it? You may just add on at the end of your descriptive statistics discussion. But don't need to paste the histogram. Understand? If you use one, the nice histogram, not necessarily. We just want the Jack Bera p-value. So because it's just one little information, you can report it after your descriptive statistic, you understand? In terms of normality, then you go on writing and so on. Okay? So, normality test, you incorporate it right after your descriptive statistic. You can put under the same section because it's quite a small part. Okay? Reliability test, you won't see it in this project paper because it's survey, isn't it? Reliability test for survey, you can create another section for this. Meaning, you got 4.1 for descriptive together with normality. 4.2, you got demographic, isn't it? You can put reliability as 4.3. For survey, you can put 4.3. Reliability test, I have shown you using SPSS to create that table, isn't it? Last week, remember? You put the table in, you interpret okay? Right? If you don't know how to interpret, you can look at journal. I think journal, they will interpret. You can follow their style. Okay? So now I will go to this part. Based on our correlation analysis, we are first going to do a univariate analysis. Okay? So univariate, right? That's why I put here. In your case, this one will become 4 point something already, right? Definitely not 4.2 lah. Univariate analysis. So what table will I prepare? I will prepare a table like this. I call my table correlation matrix. Why matrix? Because you notice on the first column and the first row, they are covering the same thing, isn't it? Yes or not? And as usual, we will start with DV, IV. If you got control variable on the first column. On the first row, the same thing. DV, IV, and the rest, if you have control variable, are your control variable. Then you key in, you follow your output, isn't it? You key in is the one correlation, the one I highlight in yellow for you, isn't it? And then the star will be the p-value, the second row, isn't it? Right? I think for SPSS, you can call up the star or something, you explore, right? Here, for me, I don't need so many cut-off points. I maybe to keep it simple, I put one star here, 5%. So, meaning I look at my p-value, so if then I follow the guideline and to see which one got star, no star. You understand? Right? So, here again, you standardize your decimal places. If you want 3, all 3. You want 4, everything 4. Okay? Understand? So, what is univariate analysis? Univariate analysis is we only focus, see my cursor, on the second column. Univariate analysis. Why second column? Because second column is showing the correlation between your DV, here DV, isn't it? And all the IV. Meaning univariate analysis is you are looking at the correlation between your DV and your IV, including your control variable. Understand? DV and IV. One pair at a time. Example, I look at the blue one. The blue one is the correlation between my DV, this is my DV, and my IV is PI. Okay? You see how I interpret that? Remember, this is positive 0.32 but no star, isn't it? Not significant. So you see my notes, I use color-coded. But before that, of course, introduce the table again, right? Table 4.2, represents the correlation matrix for all variable. Let's see the blue one, how I interpret. The correlation between, I always put, doesn't matter like DV and IV, IV and DV, but it's between, I put the full name. You want to use symbol also okay, right? This first one is the DV, and then BI is Bitcoin index, is the IV. It's positive, we saw positive, isn't it? But not statistically significant. That's all. And you see, simple only. Give you another example. The green one. Between DV and IA. IA is investor attention. Positive 0.194, but significant because got star, isn't it? Significant at 5%. Let's see the green one, how I interpret. The correlation between, again, this is the DV and investor attention, is significantly positive at the 5% level. Can you see? Right? So you can use all these words. These are normal words. You read journal also, we use the standard way to describe one. Okay? What about the pink one? The pink one, same lah. All not same lah. Positive, this one is negative, this is positive, but all not significant. But you see, I do it again, one sentence at a time. I don't group all the control variable are not statistically significant. Some impatient one are like that one. I do it one pair at a time. You understand? Alright, take your time. The mark allocation are different one, right? So meaning I will address one correlation at a time, meaning I have how many pair? 1, 2, 3, 4, 5. So you will see there are 5 sentences here. Understand? Okay? That is univariate analysis. As I say, correlation between DV and IV. That is the first part. But correlation analysis is also used to test multi-collinearity, isn't it? Right? This is a diagnostic test. How do I put it? I will put it in the next paragraph. How to check for multi-collinearity? I look at the correlation between IV and IV. You can see the difference. Don't go and mix up. Some students, they mix up univariate, they go and do DV and IV, IV and IV. I never say like that. I just say DV and IV, isn't it? Multi-collinearity, don't care about the DV. Only IV and IV, meaning I will look at where? This triangle. Correct or not? All these are the IV. Control variable is considered IV also. So meaning, I look at the shaded one and I see got anything 0.8 and above, isn't it? That is the benchmark. Have or don't have? Don't have, isn't it? Right. You need time to examine or not? Don't have, right? All below 0.8, right? So, what do I report? You see, I don't need to report like here just now, isn't it? The correlation between IV1 and IV2, no. I just say, table 4.2 also shows us the correlation between the IV and there is no multi-collinearity issue because the correlation between the IV are less than 0.8. That's the benchmark, isn't it? Okay? Enough already. Some students go and interpret IV, they follow this style. No need, waste word count. No value added. Because the multi-collinearity, we just want to know got multi-collinearity or not. Of course, if you have any pair more than 0.8, then you must say which pair, right? The maybe correlation between, let's say between maybe BI and IA is 0.95. Then you report. You pick up the one with the problem. Okay? Right? But my case don't have law, right? And if you look at my slide, I say if you can generate the VIF as well as the second level of correlation analysis. So this one, my student did it, reporting only, right? The VIF for all IV are only 1.77. The benchmark is 10. So way below 10 to confirm we got no multi-collinearity. Understand? But if you have multicollinearity here, remember I taught you how to deal with it, isn't it? Then you must explain or settle it, all your reporting here, then what is the final outcome from there before you move on. Understand? Meaning got problem also you must report the problem and then how you solve the problem. Understand? That is univariate analysis and multicollinearity all in one section. Okay? So when we are done with that, following my table, then will be the regression results, isn't it? Okay, so I will move to the regression results. Here, of course, results. Your results depend. For survey, you only need one title, isn't it? Because you have one model only, isn't it? Right? So you will just put like empirical results for the relationship between your main IV and DV everything But secondary data, you have to test it maybe using separate model, isn't it? So this is like what we do we separate This is research question 1 or RO1, right? Then later RO2, you must report in separate section. Okay? Right. So I will just choose based on his RO1 So how do I report my table? So your table will look something like this. Make it smaller, right? So I will put table 4. Don't know what. The relationship between what IV and what DV depending what you're testing right? So again, the first column, here I would prefer to type the word variable right? To at least tell what is this variable. But here, what do you report? Your DV won't be there already. You notice your table got no more DV, isn't it? The regression. It will show IV and control variable, if any, constant. Right? Okay? So you key in here because this student, they do by country, then all country. That's why he got many model. Some of you may have different model because you got more than one measurement, isn't it? Maybe you're doing your DV is profitability and you measure using ROA and ROE. So you want to save space, right? And you want to show they are comparable or not. So you have model 1 based on ROE, model 2 based on ROA. You can put them side by side, you understand? So that you don't need to create too many tables. Okay? But let's say if yours got no alternative measure, only one measure for each variable, meaning you only have 2 columns, yes or not? Don't have so many different models. Do you understand? Okay? So, right. What do I report? I make it bigger again. What do I report here? This 10.037 will be your coefficient. Meaning, in your SPSS, that is your unstandardized beta. Yes or not? The unstandardized beta, the coefficient. In your E-views, it will be your coefficient. Okay? You're going back and see where's the keyword. All the star here will be based on your p-value, isn't it? Right? And p-value, because this one is the result, we will segregate into 1 star, 2 star, 3 star. We follow standard for journal. 3 star means significant at 1%. 2 star is 5% and 1 star is 10%, like what I taught you before. But the software will not put the star for you. Some students say, Miss, where got star A? You must look at the p-value. Then you convert it to star yourself. Understand? Okay? So, and what is the bottom here in bracket? As I mentioned, figures in parentheses. Parentheses means bracket, right? Are the T statistic. You notice got T statistic one, isn't it? So we report the T statistic. Okay? If your table is only got 2 columns, then T statistic you can put here. You understand? You don't need 2 rows, isn't it? You can just bracket next to it. Understand? And that one is just presentation, up to you. Okay? Do you understand? Then you also key in observation. All these are in your software output, isn't it? R square. Okay? What else you can put? If for secondary data, you can put your David-Watson test statistic as well. Okay? Right. But what do you put under the notes to the table? the main one is you have to put the figures in the bracket stand for what? Like in this case, T statistic. This pink one show that initially you got hetero problem and you corrected for it, alright? So we put standard errors are adjusted for heteroscedasticity. The clustered by firm and year, no. I didn't teach you how to do it, so please don't copy blindly. You didn't do it, okay? And then remember, it's all in symbols, so we ask to refer back to your table, don't know what, isn't it, earlier, for symbol and definition of variable. Then you put on 3 star, 2 star, 1 star, stand for what? Do you understand? Now, how to interpret? I will first look at the pink one. Pink one is the relationship between my dV. All these are dV and this is my IV. Rm minus Rf is positive, significant at 3 star means what? 3 star is at 1%. Positive, significant at 1%. Right? Look at how I write for pink one. I can write like that. The coefficient of, just now the Rm minus Rf is market access return, is significantly positive at the 1% level. You can follow this style of writing. Okay? But you need to do something else one. But I will use one example to show you. Right. What about the blue one? Never mind, I don't go to the blue, I go to this one, the green one, because the green and blue are the same, negative, significant, isn't it? So I go to the green one. Relationship between my dV and size, and it's negative, significant again at 1%. So we follow this format. Rightfully, this format, you do it for each relationship between the dV and each of the IV, okay? You see, there are 4 things you have to write, but you are going to repeat it for all the variables. So this is just one sample. So remember, that one was firm size, isn't it? And it's positive and significant at 1%. So I can write something like this. First, I will write your results. Positive or negative, significant or not. If significant, what is the p-value? So I can put the coefficient of firm size is significantly negative at the 1% level. Okay, simple, isn't it? This one. Second requirement, interpret. Negative, what does it mean? So you interpret, meaning it shows that, like for example, when the firm size is smaller, your dV must move in opposite direction, isn't it? Right? Here I don't remember what is the dV. But you understand that interpret means if like firm size is bigger, then your dV will be smaller. Firm size is smaller, your dV will be bigger. Something like that. Alright? Simple interpretation. Okay? Or you up to you lah how you want to interpret what the negative means. Number 2. Third level, literature support from theories and past empirical study. This is where your chapter 2 literature review will come in handy. If you find negative, remember, this one is control variable. So actually the literature review is from your 3.4, right now. But depending on survey, everything will be from chapter 2, isn't it? Right? So let's say from chapter 2, you have reported positive, negative, who says what, isn't it? So you go and refer back, you can recycle, right? Recycle what you wrote in chapter 2, rephrase a bit, right? So remember, here we found negative and significant. We want to report who else found negative and significant for the same relationship between the IV and DV. So here I will write down this fella found the same thing, then I write down, okay, what he found and so on. Understand? Right? If you have theory to support why it's negative, you can also bring in the theory. Maybe behavioral finance theory say it's supposed to be negative. Then you explain this is supported by behavioral finance theory, which says that, and so on. Okay? The fourth one, this student didn't put in. Is the hypothesis supported or not? So let's say this one is testing H1. So if your H1 also predict negative, then supported or not? Supported, isn't it? Then you say therefore hypothesis 1, or you say H1 is supported. But what happened? Your H1 in chapter 2 is positive, but you found negative. Supported or not? Opposite means not supported. You understand? Okay? Right. That is if significant if you got star, isn't it? But what happened got no star? Like BM here, no star, isn't it? No star, what does it mean? No relationship. You understand? You can report as positive but not statistically significant, but it means no relationship. So when you interpret, can you say there is a positive relationship? No. No relationship. So you bring in journal also, no relationship. You understand? You understand? So it cannot be some student, first sentence okay, they say positive, not statistically significant. Second sentence still okay, they say no relationship. But then the journal, they bring in the positive one. And hey, what is going on, isn't it? You're not supporting the right thing. So if you want to bring in literature, you must say, bring in those that also found no relationship. Okay? And not significant already mean your hypothesis is not supported. Because to be supported, your hypothesis must be in the same sign, positive or negative, and must be significant. Understand? So meaning, what I shared with you here, you repeat it for how many times here? 1, 2, 3, 4. Constant don't need, constant is silent. So you repeat it 4 times, understand? Same format, repeat 4 times. Okay, you got it? But you notice at the start of my table, forget to introduce table 4.3. Let's see at the start how we introduce. Got something to write one. Table 4.3 show the regression results between, for what? Relationship between your IV and DV lah. And all of you use OLS, so just say OLS. You can write like this, like especially for secondary data. If you adjusted your standard error for heteroscedasticity, you can report it here to, emphasize, I already corrected for hetero. But remember your R square? Here you can report your R square. My R square here for model 1 is, if I convert to percentage, it's 1.4%, isn't it? Good or no good? Maximum is 100%, isn't it? Or yours is only 1.4%. Let's see how we interpret. The R square value, because here got many models, so the student put the range. If 1.4% meaning what? This indicate only 1.4% or a small portion of the variation in your DV is explained by IV. Very small, 1.4, very poor. You understand? Okay, so report the R square also before you go into every relationship. Can you understand? Okay, right. So if you got objective 2 and so on, you repeat yourself using the same technique, but you do it in a separate section like this student. After that, he go to his, I don't know, go to where? Go to objective 2, then you go objective 3, you go objective 3, objective 2, then continue until the end using the same technique. Okay? So after you do that, no more isn't it? Right? And then